Bismillahirrahmanirrahim. Assalamu alaikum. Today the topic of our session is sample size calculation. The aim of the calculation is to determine an adequate sample size to estimate the population with a good precision. Now these are the objectives of today's session, and by the end of this session you will be able to discuss significance of sampling in research, list basic assumptions in sample size determination, determine the sample size required to estimate the population mean at a given level of confidence and the margin of error, and to recognize the different factors that affect the sample size. Now, what is population sample? Population is a set of persons having a common observable characteristics. For instance, newborn babies born in Pakistan in 2021 with brown eyes. Now, what would be the difference between study population and target population? Study population is a group of individuals in a study. For example, children under 2 years of age in a community. While target population is a certain group of the population that shares similar characteristics and is identified as intended audience for research. For example, the population of a particular country and students at a particular university. And when large proportion of individual or items or units have to be studied, we take a sample. In a statistics, a population is a pool of individuals from which a sample is drawn for a study. So sample would be a subset of the population, and a sample is a portion, piece or segment that is representative of an entire population. For instance, I will give you an example. We conduct a study in which we are identifying the health issues of college students. Let us consider all the students of college. Is this a sample or population? It depends. If we are looking at college students in general, then our college students would be a subset of population. But let's suppose we are only interested in health issues of students of our college. Under these circumstances, we would view these students as population. Now, what is the importance of sample size determination? Sample size determination is a common task for an organized research. Inappropriate, inadequate, or excessive or large sample size continue to influence the quality and the accuracy of the research. Now, what would be the significance of sample size in research? Effects of inadequate sampling. If the sample size is too large, it will result in the wastage of resources, wastage of time as well as money. And if the sample size is too small, we cannot generalize our result on the entire population and it will not be powerful to demonstrate the difference. Therefore, the appropriate sample size will be required, which will result in answering research questions relatively more accurately. Now, in this slide, we will discuss about the basic elements which will be required in sample size calculation. First of all, we have a population mean. Population mean is denoted by mu, and it is defined as the sum of the values of observation divided by the number of observations for the entire population. Next, we have a sample mean. Sample mean is denoted by x bar and it is an estimate of the population mean. Sample mean is defined as the sum of the values or observation in the sample divided by the number of observations in the sample alone. Now, the next we have a study variables, and there is a need to identify study variables in order to determine the sample size. For instance, I will give you an example that what is the prevalence of iron deficiency anemia in the pregnant women. So our parameter of interest would be the prevalence of iron deficiency anemia in the pregnant women. So pregnant women would be our study population and prevalence would be our dependent variable. Now we have a population size. So in population size, the statistician and researcher must be prepared to answer a question that how large a sample size do I need to obtain a statistically significant or a meaningful result. Because when we take a small portion of sample size, we are not pretty sure, we are not 100% sure that if sample statistics represent the entire population. Next, we have a margin of error. It indicates that how much error can I live with in estimating the population mean. It is because no sample is perfect. It is a decision. It is actually a decision about the closeness of expected mean to the actual mean of proportion. And margin of error is denoted by small e. Now, next we have a confidence interval. It means that what level of confidence is needed in our estimate. A confidence interval expresses a range of values within which we are pretty sure that where our population parameter lie. Next, we have a degree of variability in the population. It reflects the degree of spread in the data set, and the variance and the standard deviation, the measures of the variation in the data set. We will discuss all this in our next slide. Now, one of the elements which will be required to determine sample size is the margin of error. Margin of error is denoted by small e and is also known as sampling error. So, what is sampling error? Sampling error is a variation from one sample to another. For instance, I will give you an example. If I take a repeated sample from the same population, then the results obtained from one sample will differ from the results of another sample. And this type of variation from one sample to another is called the sampling error. And the factors that influence the sampling error are the size of the sample. If the sample size increases, the sampling error would decrease. So it is the range in which the true value of the population is estimated to be. And this range is often expressed in percentage points, that is plus minus 5% or plus minus 1%. 5% means that there is a 5% chance of committing an error, or you can say that 5% means that there is a 5% chance that our estimate will not contain or will not capture the population mean, and 1% means that there would be a 1% chance that our estimate will not capture the population parameter or the population mean. For example, if a researcher finds that 70% of the students in the sample have adopted a recommended practice of submitting the assignment with a precision rate of plus minus 5%, then he or she can conclude that between 65% to 75% of the students in the population have adopted the practice. Now, what will be the effect of sample size on the margin of error? As you can see from this equation, that margin of error is directly proportional to the square root of the sample size. So if margin of error is doubled, then the sample size will be multiplied by 4. And if the margin of error is triple, then the sample size will be multiplied by 9. Now, another element which will be required to determine the sample size is the confidence interval. So it is the interval that attempts to capture the true population parameter. Or you can say a confidence interval expresses a range of values within which we are pretty sure that where our population parameter, that is where our population mean lie. And in simple words, you can say that confidence interval is designed to capture the population mean. And confidence intervals of great value in making estimate because they allows us to estimate an unknown parameter, that is a population mean, with little room for error. This is expressed in percentage point. For example, 90% confidence interval, 95% confidence interval, and 99% confidence interval. 95% confidence interval is conventionally used in medical research, and the researcher has to select a confidence interval in his or her study. For instance, if a researcher has selected a 95% confidence interval, it means that researcher will be confident that 95 out of the 100 sample will have a true population value. In simple words, you can say that 95% will contain the population parameter, that is a population mean, and 5% will not contain the population mean. And remember one thing, that 95% confidence interval will be narrower as compared to the 99% confidence interval. And the margin of error 95% confidence interval would be 5%, and in 99% confidence interval the margin of error is 1%, it would be less. So what does 90% confidence interval means? 90% confidence interval means that for every 100 confidence interval we calculate from the sample data, about 90% of them will contain the population parameter, that is the population mean, and 10% will not contain the population parameter. Now here you can see the equation, that is confidence interval is equal to 1 minus alpha, where alpha is the level of significance, and level of significance selected at values of alpha such as 0.05, 0.025, so on. And this level of significance, it is a measure which tells us that how significant our result is. Now, what would be the effect of sample size on confidence interval? If the sample size increases, confidence interval will be narrower and the margin of error will be increased. As you can see that this is the normal distribution curve, and the property of a normal distribution curve is that it has the appearance of a symmetrical bell shape which is extending infinitely in both directions. Here the researcher has selected or set the confidence level at 95%. As I already told you in the previous slide, that 95% confidence level means that out of the 100 sample, 95% will capture the true population mean, and population mean is denoted by mu, while there will be a while the unshaded area, you can see that there it shows that this unshaded area both on the left side and right side, so 2.5, it will be 2.5% on left and 2.5% on the right side, it will make 5%, it will be symmetrical. So it shows that there will be a 5% chance that this interval does not capture the population mean. Now, another factor which will be required to determine the sample size is the degree of variability. So, degree of variability refers to the degree of spread in the data set, or it refers to a amount of spread around the mean, and it refers to the distribution spread of attributes, that is the variance and standard deviation in the population. Both the variance and standard deviation are the measures of variation in the set of data. What is standard deviation? Standard deviation is basically average distance from the mean, or you can say that it is a square root of the variance of the observation. And variance is, and what is variance? And variance is a mean squared deviation from the mean. So greater the deviation, greater would be the variance, and the more heterogeneous our population would be, and the larger the sample size will be required to obtain a given margin of error. And the lesser the variance, the more homogeneous a population will be, and the smaller the sample size would be required. And low standard deviation means that our data is clustered around the mean, and high standard deviation mean it indicates that the data is more spread out. And if the standard deviation is close to zero, it indicates that the data points are close to mean, whereas high or low standard deviation indicates that the data points are respectively above or below the mean. Here I will give you an example of a variance, that is, one source of variation might be a personal characteristic, that is age, gender. Another could be individual variation and observation. For instance, observation taken before or after exercise may differ. So the greater the deviation, greater would be the variance. Now, strategies which will be required for determining sample size are to conduct a census for a small population. For if the population is well known, approachable, accessible, and countable, then we conduct a census and use entire population. But we have to consider about the budget and time constraint. Secondly, we have used a proportion of using a proportion of a similar study, for which we have to review literature in our discipline And for instance, we are conducting a study on the prevalence of a pneumonia in the children. So we can use the prevalence of a subject of interest from a previous study, and but the pitfall or drawback is that the mistake of others will get transferred into our study. Now, next we have using a standard table. You can rely on published table which provide a sample size for a given set of criteria. But again, the pitfall or drawback is that the mistakes of other will get transferred into our study. There are certain formulas also from which we can determine the sample size. One of the formula is the Cochrane formula, which will be used for the infinite population. Other the Yemen formula for the finite population. And these are the manual methods of calculating sample size through these formulas. We can also go for online sample size calculation through a sample size through a through a software, that is a AppInfo, or through a WHO calculator. Now, how to determine sample size? Researchers and statisticians have developed certain formulas for the sample size determination that provide a minimum requirement of the sample. And for the ease of the researchers, tables and software for the sample size determination are also available. The most common software for the sample size determination are the AppInfo, WHO sample size determination for the health studies, and so on. Now in this slide we will go for Cochrane formula for calculating a sample for proportion, and it is appropriate in situation with the infinite population or large populations. It is denoted by n naught, which is the sample size, and a square of the z, p, q, or degree of precision, square of the degree of precision. Where n naught is the sample size, z value can easily be calculated or taken from the z table at a given confidence level, and p is the estimated proportion of attribute present in the population. You can get it from your previous study, this proportion. And q is the probability of failure, which is equal to 1 minus p, and e, as we already discussed in our previous slide about the margin of error or degree of precision. Now the z value or z score correspond to your chosen confidence level, and these are usually z table available that tell you the z score. You can then insert that value into the formula. Below are the values for the most commonly used confidence interval. For instance, your confidence level for 95, if the confidence level is 95%, the z value would be 1.96, and for 99% would be 2.58, and for 90% is 1.65. So basically z scores are standardized or normalized, so they allow scores on different normal distribution to be compared. I'll give you an example of z score, that a person's height should be compared with his or her weight by means of his or her respective z score, but provided that both the variables, that is the weight and height, are should be present in the normal distribution. Now, this is an example of a sample size calculation for a finite population, and we will use a Cochrane formula in this. Now, let us discuss the example. Assume there is a large population and we do not know the proportion of individuals who undergone the screening test for COVID-19. Therefore, we assume p is equal to 0.5. Furthermore, suppose we set a 95% confidence level and 5% precision. Z value at 95% confidence interval is 1.96, and the resulting sample size would be n naught is equal to z square p into q over margin of error, square of the margin of error. So we have a proportion is given, that is 0.5, and we will take the z value from the table, that would be 1.96. We will do the square of this, and q will be equal to 1 minus p, which will be 0.5, and margin of error will be 5%. So we will put margin of error, that is 5% will be equal to 0.05, and we will do the square of this, and the resulting sample size would be 385 individuals. Now, this is a Yemen formula for calculating sample size for finite population, and Yemen provides a simplified formula to calculate sample size in case of finite population, where n is equal to capital N, which is our capital N is our finite population, over 1 plus capital N, that is finite population, into margin of error, and square of the margin of error. So where n is equal to sample size and capital N would be our population size and E would be our margin of error. Now here is an example of the Yemen formula. Uh, Suppose there are 5,000 farmers in a certain locality and you want to conduct a survey on their willingness to adopt the new farming technology. The margin of error is 5% and we set a 95% confidence interval. Z-value at 95% confidence interval from the table is 1.96 and the resulting sample size would be, now we will put the values in the formula. As the finite population is given, that would be 5,000 farmers. So we will put this finite population, that is which is denoted by capital N, it is 5,000, and the margin of error in this case is 5%, which will be equal to 0.05, and we will do the square of that, and that is 1 plus n. We will put the finite population, and our resulting sample size would be 371 farmers that will be willing to adopt the new farming technology. Now this is the sample size formula for the estimation of the population mean. Uh, Here you can see that this small line is a minimum sample size required. Z alpha by 2, this value will be taken from the table at the selected level of significance, and this is a population standard deviation which is denoted by sigma, and where E is a margin of error, and where alpha over here is a level of significance. Usually it is 0.05 or 0.01. So this level of significance tells us that how significant our result is, and alpha is usually set at the values of 0.05 or 0.01. So if population standard deviation is known, we use the normal distribution z score, and if population standard deviation is not known, we can use the sample standard deviation. Here is an example of sample size formula for the estimation of population mean. Suppose we need to estimate the mean cholesterol level of a population within 5 milligram dl of the true mean. We learned that sigma, this sigma is a population standard deviation is 20, it is given, and we want to estimate with 95% confidence that this x bar, this is a sample mean, the sample mean is within 5 units of the mu is the population mean. So we obtain it as follows. So this 5 milligram per dl it shows the closeness of the expected mean with the actual mean. And it is clear from here that x is within the 5 units of population mean. So it is our margin of error. It is our margin of error. Now putting the values in the formula, where n is equal to z alpha by 2 into population standard deviation over margin of error, we will do the square of all the values, where z alpha by 2 is taken from the table, and how we will calculate the alpha by 2, as I have told you in my in the previous slides, that alpha is equal to 1 minus confidence interval, and confidence interval is given in our scenario, that is 95%, which will be equal to 0.95. So 1 minus 0.95 is equal to 0.05. So our alpha by 2 would be 0.05 over 2 is, which will be equal to 0.025, and from the z table we can get the z value of z alpha by 2 which will be equal to 1.96. Z alpha by 2 is basically a value. It is a single value called the critical value at the given level of significance, and we will take this value from the table. from the Z table. So we will put on these values in the formula for the population mean. That is, the alpha by 2 is given, that is 1.96, and we will do the square of this, and population standard deviation is 20. We will do the square of this, and then E is a margin of error. Margin of error is 5%, which will be equal to 0.05. So we will do the square of this, and our the resulting sample size would be 61.46. Now this is an example of calculating sample size for population mean. This is another example. Suppose we want to estimate the average birth weight of children born to non-smoking women in community within zero point 0.2 of its actual value with 95% confidence. Assume the standard deviation of birth weight is 0.5 kg. Find the required sample size. Here you can see that this zero point 0.2 indicates the closeness of expected mean with its actual value of the population, actual value. So it is our margin of error, where the standard deviation is given in this scenario, that is 0.5 kg, and now we are required to calculate the sample size. Now this is a sample size formula for the population mean, as we have already discussed, where n is equal to z alpha by 2 into population standard deviation over the margin of error and square root of all the values, where we will calculate the take the z alpha by 2 value from the table, but for which alpha is required. So as we know that alpha is equal to 1 minus confidence interval, so alpha is basically a level of the significance, and it is this level of significance tells us about how significant a result is. So we will calculate the alpha from this equation, and as we know that confidence interval is given, that is 95%. So 95% will be equal to 0.95. We will put this 0.95 in this, which will be equal to 0.05, and alpha by 2. Now we have to calculate this. We are actually calculating this alpha by 2. So alpha by 2 will be we will take alpha by 2 will be take the value of alpha, that is point we have just calculated, that is 0.05 over 2 is equal to 0.025. So z alpha by, now we will calculate we will look for this z alpha by 2 value at 0.025 level of significance in the z table. So that value would be 1.96. So now we will put on all the given values in the formula in order to calculate the sample size. Z alpha by 2 is 1.96, we have just calculated, and we will do the square of this, and population standard deviation is given, that is 0.5 kg. We will put on this value and do the square of this over margin of error. Margin of error is given, that is, this is the margin of error, that is 0.2, and we'll do the square of this, and the resulting sample size would be 24. Now in short, we can summarize our today's session on sample size calculation, that if sample size is too large, it will result in the wasting of resources, and if sample size is too small, we cannot generalize our result on the entire population, and it will not be powerful to demonstrate the difference. And if sample size increases, the confidence interval will get narrower and margin of error would be increased. And next we have a degree of margin is directly proportional to the square root of sample size. If margin of error increases, if margin of error is tripled, then the sample size will be multiplied by 9. Now comes to standard deviation. If in case of a high standard deviation, there would be a greater spread out, greater variation, more heterogeneous the population will be, and the larger would be the sample size. These are the references for the today's session. Thank you.